This is our final presentation on the dynamic changes in starch metabolism and endogenous hormones during stolon formation in Tulipa edulis. So our introduction, some background information. Tulipa edulis is used as a medicinal herb. The bulb is used to treat certain cancers. It reproduces asexually, primarily via stolon, and the number of stolons directly influences the reproductive index. The importance of this topic. Stolon formation. Oh, sorry. Stolons is a formation of organogenesis, multi-step process that's affected by endogenous hormones and nutritional factors. Carbohydrates, especially sucrose, are strong indicators of underground storage organ formation. Sucrose is used directly as a carbon source or converted to starches for storage. Starches are converted to reducing sugars for carbon skeletons and energy. This is an exploration of mechanisms involved in stolon formation, improving production to meet market demands. The objective of the study is to study the relationship between carbohydrates and starch formation, accumulation, and decomposition.
For the first part of our materials and methods, we have the plant material and growth conditions. Essentially, all plant material in the study was grown in standard greenhouse conditions. Bulbs were chosen for uniformity, and samples were collected at 3 different periods: an initial period of 41 days, a middle period of 118 days, and a later period of 133 days. Fresh weight samples of stolon were collected at the listed times and frozen until analysis. For the determination of carbohydrate content was determined via colorimeter, along with a heat extraction and centrifuge, measured soluble sugars, starches, sucrose, and fructose. For the assay to determine protein content and amylase activity, samples were ground and extracted, and a supernat was used to measure soluble protein content and amylase activity. For measuring key enzymes of starch synthesis, essentially another extraction was done, and this measured AGPase, soluble starch synthase, and granule-bound starch synthase. For the determination of endogenous hormones, there was another extensive extraction, purification, and determination of endogenous levels of IAA, GA, ABA, ZR, and all this was done by the indirect enzyme link immunosorbent assay technique.
The gene expression analysis by QRT-PCR was an assay for levels of mRNA of associate putative key genes of stolon formation. Putative unigenes involved in sucrose and starch metabolism ID'd on the basis of transcriptome sequencing and annotation. The primer sequences are listed here in Table 1. The PCR conditions were at 95 degrees Celsius for 40 cycles of 95 degrees Celsius and 58 degrees Celsius. Relative expression levels of select genes were calculated using the 2- delta CT method. For statistical analysis for the data presented in figures was one-way ANOVA using SPSS. The significant differences were determined using Duncan's multiple range test at a 0.05 p level. And our results. So the content of total soluble sugar, sucrose, reducing sugar, and fructose was significantly enhanced in the T2 stage. The starch content was significantly higher in the T2 stage than the T1, which can be seen here in figure 2B, sorry. The soluble protein content decreased continuously during stolon formation, the highest being in T1 and the lowest in T3. There was a significant decline in content of non-soluble protein during stolon formation. SS and SPS activity was decreased from T1 to T2, reaching a minimum values in T2 and then increased slowly after that, which can be seen in figure 3A. SPS activity was always lower than SS, and AB significantly decreased during stolon formation. AGPA increased gradually from T1 to T2 and then had a rapid enhancement, which can be seen in figure 3b. SSS and GBSS had similar trends with a rapid increase from T1 to T2 and then a slight decrease afterwards.
So for our results, the correlation between the analysis of carbohydrate content and the carbohydrate-related enzyme activities, SPS was negatively correlated with the total soluble sugar, sucrose, reducing sugar, and fructose content, meaning the more SPS there was active, the less sugar content there was in the cell because it was being consumed. Amylase activity was also negatively correlated with the same total soluble sugar, sucrose, reducing sugar, and fructose contents. Again, because the more production, the less sugar there was. There were positive correlations between starch content and starch synthetic enzyme activities, however. And going on to the next slide. So these hormones were produced in varying concentrations. The stolon formation was best produced during low ratios of ABA to IAA. There was no significant change in IAA throughout the stolon formation, but as ABA did decrease, the stolon formation increased, meaning that as the ratio got lower, the stolon formation got faster. So there were 3 genes that were analyzed using the QRT-PCR. The expression of the SS gene was higher in the initial stage of 41 days than it was in either the middle or the later stage of 118 or 133 days. The SSSI gene had a higher transcription level in T3 than the prior 2 stages, meaning it is more as an end result gene to be expressed when a storage organ is completed its formation. And the SSSI2 gene expressed higher in both the later stages than the initial stage, meaning it is something that is formed later in a storage organ synthesis. Relevance and practical implications of this study. So starch production was highest in the middle stage of 118 days, which would be relative for other plant species, but this implies that nutrients will be required in a higher demand in order to build up starch contents during the, I guess you could say, main stage of a reproductive organ synthesis. So if you have a crop where you're trying to build some storage organ, it's not going to need it necessarily at the beginning because everything will be too small to effectively use all the nutrients you're providing, nor will it need it at the end because everything is sort of set in stone. It's sort of how if you see a deficiency in a plant, you've kind of already missed your window for correcting it on that tissue. So this can be applied to nutrient application and timing and when it's going to be most effective for starch synthesis in a plant and hormone synthesis.
And this is our works cited. Thank you.